So in this video, we're talking about calculating the mass and natural abundance, okay? And what the process behind this. So I have this problem here. It says that bromine has two naturally occurring isotopes, okay? Br79 and Br81. It has an atomic mass of 79.94 AMU, atomic mass units, okay? The mass of bromine 81 is 80.9163, okay? And its natural abundance is 49.31%. So calculate the mass and the natural abundance of bromine 79. So this becomes kind of an algebraic problem, okay? And let's break it down. We know that bromine, okay, its mass and its natural abundance in any case has to be equal to the addition of the two isotopes. So bromine 79 plus bromine 81, okay? The atomic mass unit of bromine has to be equal to the addition of these two. And so, first of all, let's find the natural abundance of bromine 79, okay? Well, if the natural abundance of bromine 81 is 49.31%, okay, then simply if we subtract 100, so let's use 100%. If we take 100% and subtract that from 49.31%, then in this case, the naturally BR79 natural abundance has to be 50.69%. If I take the difference of these two, and everything is always out of 100, so we should know that by now. So the only thing I do is just simply take 100% and I subtract 49.31 from it to get the natural abundance of bromine 79. So in this case, 50.69% would be the natural abundance of Br79. Okay, so we found its natural abundance. Now we need to find its atomic mass. Okay, and so we know how this goes. We always convert to decimal and then multiply by its we convert to decimal and multiply it by its atomic mass unit. And so how do we do it? Well, in this case, let's do it by variable first. We know that bromine overall in general has to be equal to Br79, which essentially is its fraction of isotope times its atomic mass unit. Okay, well, in this case, we know its natural abundance. We don't know its mass. And so we could replace this by an x. So we could say the mass is x, okay? And all we're going to do is simply multiply x by its natural abundance, okay? And its natural abundance is going to be what? 0.5069, because I got to convert the percentage to a decimal. Okay, so we get x times 0.5069, and we're going to simply add that to Br81, which happens to be 80.9163 atomic mass units, but I got to convert its relative abundance first. Okay, and so if I convert that by taking 49.31 divided by 100%, okay, got to convert it to a decimal. Okay, I'm going to get 0.4931, and that's going to be multiplied by its atomic mass unit, which happens to be 80.9163 AMU. Okay, and so essentially what we're doing now is just solving for x. We know the atomic mass unit of bromine. It's given. It's 79.904. And so if we plug this in, 79.904 AMU, well, that is equal to 0.5069x, okay, plus, well, I'll take out my calculator and multiply these two. So I get 0.4931 and multiply by 80. We can multiply by 80.9163. I'm going to get 39.8998, and just leave it at that. Okay. Okay. And this is AMU. AMU. Okay. And if I'm solving for x, well, I need to subtract 39 on both sides, right? So this becomes 39.8998. Subtract 39.8998 AMU. Okay, and so essentially I would leave with, I'm going to be left with 0.5069x. Okay, and if I do the subtraction for this one, I'm going to get 40.00417. Okay, essentially if I'm solving for x, which is BR79's atomic its mass, then I just divide by 0.5069 on both sides. Okay, and 0.5069 on both sides. And so when I do that, well, my answer should be around x should be equal to 78.92 atomic mass units. Okay, and this is in AMU, so I'm sorry, but that's, notice that when I divide nothing by AMU, I'll get AMU. So x is 78.90 AMU. All right, and this is another way of saying BR79's mass is equal to 78.92 AMU. Okay, so this is always solved for the mass of, the mass and the natural abundance of any isotope. Okay, it's just it's a problem. What we should know, the important point, it's algebra, but what we should know, the important point is, all we're doing is, first thing we need, this important, is that the natural abundance we have to convert into a decimal, and all we do it was just to simply divide the percentage by 100%.